Polynomials with multiple variables within the same problem. So not just x or not just y, but maybe x and y in the same problem, or c and d, or m and n, or something like that. Simplify polynomials with multiple variables the same way you simplify polynomials with only one variable. You just need to make sure they're like terms. And remember, if you have x and y, if x is squared and y is cubed, then it's got to be x squared y cubed to be a like term, and it can't have any other variable in it. Okay? So remove the parentheses, combine like terms. Recall, for terms to be alike, they must have the exact same variables to the exact same respective powers. That's what I just said. All right? And so here, let's evaluate this. Evaluate if x is 2 and y is negative 3. Let's evaluate 2x squared minus 4xy plus y squared. So this is not necessarily doing something with a polynomial, but it is, well, it's evaluating, I guess. So x's and y's, but it has both x and y in it. So what we're going to do, we're going to take this, we're going to say 2 times something squared minus 4 times something plus something squared. Okay? So this really becomes, if I look at this, this is going to be x. I'm going to do x in purple. So this is x and this is x, right? So we're going to do what? Let me erase that. It's going to be 2 for this and 2 for this. And then in the blue, we'll come back and say, okay, y equals negative 3. We'll do in that. So this is y and this is y, right? So then for the y, we're going to plug in negative 3 for both those, right? So the purple, the blue here, and the purple was the x. And so let's go back and simplify this. Now we're going to say, we're going to do 2 squared first. It's going to be 2 times 4. And then here, this is its own term. This is its own term. So remember, you can follow the order of operations within a term. All right? I'm going to be strict on this one, so I'm going to leave it negative 4 times 2 times negative 3. But you actually could go ahead and start multiplying those together. But since we have exponents, I'm going to do those exponents here. Plus negative 3 in parentheses squared is negative times negative is positive 9. Okay? Now I'm going to multiply from left to right as I get to it. So multiply that gives me 8. And then multiply that gives me minus 8 times negative 3 and then plus 9. And then here 8, I'm ready minus 8, but I have another multiply, so do that next. So I have 8. And I have negative times negative is positive, so that's plus 8 times 3 is 24 plus 9. Put my 8 plus 24 together, and that's going to be 32 plus 9, and 32 plus 9 is 41. Okay? So that final answer there is 41. And you could have done 8 plus 9 is 17, and at the same time you multiplied the others. Again, once you get a term finished simplifying, you can combine those terms. You just need to finish simplifying all the terms before you combine them all together. All right? So that final answer there is 41. So if you did the order of operations, even if you mixed a few things up and did it a little differently, that's okay, because if you got 41, it's okay. Right? But within each term, you can do order of operations. So I did this basically the long way because I strictly followed exponents, multiply, then divided or added. Added or subtracted, I'm sorry. So here, we're just going to basically rehash some of the same things. So I have videos on adding polynomials, subtracting polynomials, multiplying like bases, distribution, FOIL, bigger than FOIL, special products. We're going to do all those things with x's and y's, or m's and n's, or p's and v's, or maybe even x, y, and z all in the same problem. And that's okay. All right, that's okay. You can do that. So, but it's just with multiple variables within the same problem. So here, this is a polynomial x squared y and x squared y and then x, y, and x, y. It's built the same. Same thing we had before, it just has extra stuff in it. So then I'm going to line these up. Negative 5x squared y plus xy. And there's a plus here, so it doesn't change any of those signs. So the 8x squared y plus 3xy. And I tell myself, okay, this 8 is positive, so I'm going to put it plus since I'm lining it up vertically. So negative 5 plus 8 is a positive 3, and that's x squared y. Those are like terms. And then this is one of them. We don't write it, but it's one. So 1 plus 3 is going to be plus 4 of those xy terms. So 3x squared y plus 4xy. All right. Whew, don't have a heart attack, right? This is just a real big one. And it's really real big just because it's got a lot of letters in it. It's got m's and n's and 3 terms and 3 terms. But look, this is m to the 4th n squared, and so is this one. So those two are alike. M squared, N squared, M squared, N squared. Those are alike. M in. Guess what? Those are built the same. That's really great. When they're built the same, they line up vertically really nicely. The other thing is they're added, which means I don't change any of the signs after it. That really is nice. So let me come down here. 6m to the fourth n squared minus 10m squared n squared plus 7m n. Okay? So look, let me remind you in the videos, I haven't said this in a while in some of them, so if I'm working something and I go way too fast, you can pause it. Rewind it, rewatch it, right? That's the beautiful thing about a video. So I may fly through this, but just pause it if you need to, take a breath, copy it down, then hit play again, listen, then pause it, copy it down, however you need to do that, okay? So, and rewatch it if you need to. So then we have the 4m to the fourth n squared, and it's negative, we don't change it. The 3m squared n squared, it's negative, we don't change it. And the mn, and it's also negative, we don't change it. We don't change it because of that plus. We only change it if it was a minus. So here we have 6 minus 4 is 2 m to the fourth n squared. Remember, when you combine like terms, you get a like term. So if these are m to the fourth n squared, so does this. It's got to be. And then here, m squared, n squared. And we got a negative 10 and a negative 3. You're going to add them together and get 13 and keep it negative. Two negatives, you add them together, keep it negative. And then plus 7mn minus mn is going to be plus 6mn. Right, they're both mn's, and then 7 minus 1 is positive 6. And so that is your final answer there. All right, so it was harder writing all the stuff down than it was actually doing that, right? You can do 6 minus 4, you can do negative 10 minus 3, and you can do 7 minus 1. This is a minus. Ooh, it's a big one, right? Little first parenthesis and then minus a big one here, right? So what are you going to do here? These are not built the same, right? You just have 2 terms and 4 terms. They can't be built the same. They don't have the same number of terms. You're going to take this negative and distribute it to all 4 terms. You're going to change all 4 signs. But when I look at it, I notice that x cubed is the first term. These match up and these match up. So then I need to leave space for these 2 terms, I guess in the middle, since they're in the middle on that big one. So when I line this up vertically, I'm going to copy the first one down, x to the third, and I'm going to leave space for the next one and space for the next one. I'm going to come over here and go minus, not 4, minus y cubed. All right? So I left my space. Now I come down here and go, okay, 4x to the third, and I got a 3x squared y, and I got a 2xy squared, and I got a 5y to the third. Right, so I left my little spaces here for these things, right? The x squared y and the xy squared. And by the way, these terms are not alike, right? The x is squared here and here the y is squared. Those are not alike terms. Those are not like terms. So we cannot combine those. So, but I do distribute the negative. So this 4 was negative. Now it's going to be a positive 4x cubed. That's a plus 3x squared. It's going to be minus 2xy squared. It's going to be plus. And plus 5y cubed is going to be minus 5y cubed now, right? We're changing all the signs because we subtracted. And look, there's nothing up here, so these 2 terms right here are just going to be brought down, okay? So, but the first one, x cubed plus 4x cubed, remember there's a 1 there, so that's what? That's 5x to the third, or cubed. And then we get minus 3x squared y, we're just bringing this down, plus 2xy squared, bring that down. And then minus, again, that's 1, so minus 6y to the third. And there's your final answer. The big deal there was changing the signs and then leaving the empty space if you did it vertically, or combining the correct terms if you do it horizontally. All right? So test yourself if you want to. Pause the video, go back and do this horizontally and see if you get it right. Do that on the one before that and the one before that. All right? These 2 problems, if you glance at them, may look very similar, but they're very different. The first one is what? 1 term, a monomial, times another 1 term. I know there's a negative here, but that doesn't separate it. That's a leading negative. So that's 1 term times 1 term. When you do that, you simply multiply factors. The 3 times the negative 5 gives you what? Negative 15. Then you take the x to the 5th times the x to the 7th. Like basis, you do x to the 5 plus 7, and you get what? X to the 12th. And then y to the 4th times y to the 11th. Again, you add the powers because it's like basis, and y to the 4 plus 11 is 15. So negative 15, x to the 12th, y to the 15th. And that's your final answer. You're just simply multiplying each one of the factors there because that is 1 term, a monomial, times another 1 term monomial. Okay? Monomial means 1 term. I'm really being redundant there. Here, however, on the next one term, even though it has three factors, times a term and another term. This is two terms. This is a binomial, right? How do I know it's a binomial? That separates it. There's no negative over here to separate it. Remember, this negative is leading in front of the 5. There's nothing in front of it, so it doesn't separate it from something else. So over here, this is a monomial times a binomial, so it's distribution. You're going to take this term and multiply it here and here. So 5 times 4 is 20. X squared and x squared is x to the 4th. 2 plus 2 is 4, and then you have the y. And then minus 5 times 9 is 45, and you have x squared, you bring it down, and then y times y, you add the 1 to get y to the second, or y squared. So that was distribution. The first one in red over here, not distribution, the one on the right, is distribution. You see the difference between the two. You need to be able to identify that, because when you take a test, you can't be trying. I have students all the time doing this. I can't. No, that's not what you do there. That's not FOIL. Don't be trying to do that, distribute or FOIL or whatever. No. And this one isn't either. This is just distribution on the right. The one on the left is just a monomial times a monomial. You have to identify what to do. If you don't identify it correctly, I talk about this ad nauseum. If you don't identify correctly, then you can't get it right. Just like an athlete. If a football player is on defense and he has been studying game film and he looks at the other team and goes, they're going to run a slant. But he's read the play wrong, he's read the formation wrong, and they run a go route. What happens when he plays the slant and tries to step across the guy's way coming across the middle to intercept the ball, and the guy's running down the field wide open? The cornerback looks like he's silly and doesn't know what he's doing, right? Now, he's a great athlete. He's on the football team. He's playing cornerback. He's a good athlete. He just misread the play. So he got it wrong. And that's the same thing. If you misread what to do with the problem in math, you're going to miss it. So you got to read what to do right. So here, what am I doing? Well, a binomial, two terms, and what's between there? Nothing. So that's FOIL. Y'all, this is FOIL. This is first. So what is x times 3x? That's going to be 3x squared. Then we have outer, which is going to be x times negative 7y, which is minus 7xy. You can put yx or xy, it doesn't matter. And then here, inner, you got 8y and 3x, all positive. So 8 times 3 is 24, and that's xy again, and it's positive. And again, I'm lining up my xy's. That's why I wrote it underneath. And then last is going to be 8y times negative 7y. That's negative 56y squared. And I wrote it by itself because there's no other y squareds up here. There's x squared, but not y squared. So then I'm going to come down here and say, okay, let's put this all together. 3x squared, subtract them. That's going to be plus 17xy, and then minus 56y squared. And there is your final answer. So it's just FOIL. It's just FOIL, but it had x's and y's in the same problem. So when you multiply the two x's, you had to add the exponents. Multiply the two y's are like bases. But when you multiply x times y, you just write xy. They're not like bases. You don't change those exponents. And then you don't change them when you combine them here. You leave it xy. All right? That's another big idea of this problem here. All right? Let's look at another one. 2 terms times 2 terms. So guess what? First, outer, inner, last. So m times m is m squared. Then m times plus 5n is plus 5mn. Then here, inner, we get negative 5n times n is minus 5mn. And then last is going to be what? 5n and negative 5n is going to be minus 25n squared, because a positive times a negative or negative times positive is negative. So this is m. Let me change it. This is m squared. That cancels, right? Plus 5mn minus 5mn, and then minus 25n squared. Again, I don't like this big gap in here, so I'm just going to come down here and write m squared minus 25n squared. All right, and there it is. That's, again, just foiling. That's one of those quote-unquote special products, but I don't teach the formula. I just say foil it, and then you got to recognize that those things cancel. All right? Just like you would recognize that they cancel any other time you were trying to combine them. Nothing special about it. 2c plus 3d squared. Again, this is a special product, but what does it mean to square something? 2c plus 3d times what? Times 2c plus 3. Just multiply it by itself. And then once you do that, then you come through here and you say first, outer, inner, last. So first, 2c times 2c is 4c squared. 2c times plus 3d is plus 6cd. Then you have another plus 6cd here for inner. And last is 3d times 3d is plus 9d squared. And then I'm going to combine this. See, we got 4c squared. Those don't cancel. It's going to be plus what? 12cd and then plus 9d squared. And there's your final answer for that one. All right. So again, it's a quote-unquote special product, but all you do is write it down twice and foil it. And you're good at foiling. So you might as well do that. And you begin to see the patterns as you do more of them. And then here, this is one of the binomial times a trinomial. You take the x and you distribute to all three. So what is x times x squared? It's going to be x to the third. X times a plus 6xy is plus 6x squared y. And then x times negative 2y squared is going to be minus 2xy squared. And typically we just put the letters in alphabetical order. It's not wrong if you put y squared x. But if you write them all xy squared or x squared y or xy, whatever, x first, y second, then you easily see if you write them all x first, y second, or all y first, x second, doesn't matter, then you can easily see which ones go together as far as like terms go. So these things are not like terms, right? The x is squared, the y is squared. Those are not like terms. And again, we knew if you can't combine them up here, you better not be able to combine them when you distribute. So now what do I distribute? I come back and distribute this y to all these, and I get x squared y. So it's x squared y. That goes under the same term. Those are like terms. That's why I put it there. And then y times 6xy is plus 6xy squared. And then y times negative 2y squared is minus 2y to the third. And notice I wrote it out by itself because nothing else was like it. So I'm going to combine these. This is going to be x to the third. We're going to bring that down. We're going to bring down the 2y squared. Cubed. And then these go together, right? X squared y. So that term, unless it cancels, is going to be x squared y. And it's going to be 6 of them plus 1 of them, right? It's understood 1. It's going to be how many? Plus 7 of them. And then here, these are both xy squareds. So it's going to be xy squared. And we're going to have negative 2 plus 6. 6 minus 2 is 4, and 6 is bigger, so it's plus. And there is your final answer for that one. So hopefully this video has helped you with if you have multiple variables inside of each polynomial or inside of polynomials and you're adding and subtracting or multiplying them. All right? So good luck with it and good luck with algebra.